Hello again, this is Alireza. In today's video, we're going to fully understand about IP prefix list concept. In this video, we're going to learn what is IP prefix list used for and how we can configure it in all routing protocols. But first of all, one question. What is exactly IP prefix list? An IP prefix list in Cisco IOS is a method used to filter or match network prefixes. In fact, IP addresses with subnet masks in routing protocols. It's mainly used to control route advertisement, meaning you can define which routes are allowed or denied when sharing routes between routers. For example, in BGP, EIGRP, OSPF, redistribution, and etc. So IP prefix list is only designed to filter route updates. Hence, you cannot use it for user conditioning as we will do it in ACLs. This is a syntax for defining IP prefix list with a very practical pattern you can memorize or write down somewhere in order to remember that forever. You have to input this command, IP prefix list, and then the name of this list, and then you can input your sequence number with keyword SEQ, and you have to define it is permit or deny, and you have to input high order bit pattern, which is your network, and you have to input a slash followed by the high order bit count, which specifies the length and range of your network. Now it is time to define the subnet mask condition in CIDR format using GE, which stands for greater than or equal to, or LE, which stands for less than or equal to. Here's some example of IP prefix lists in real environment. We go to global mode and we input IP prefix list and then the name of the IP prefix list, which is in this case AB. And it is time to input your sequence number with SEQ. Sequence number, let's say 15, and then you have to specify this permit or deny. In this case it is permit, and then you have to input your high order bit pattern, which is your network. In this scenario it's gonna be 10.168.0.0, and then you have to input slash followed by high order bit count, which is your length or range of your network. In this example it's gonna be 13 and its format is CIDR, and then you have to input the second condition. In this example it's gonna be GE, or greater than or equal to. It's gonna be 24 in this example. And after inputting that, our IP prefix list with name AB is created. Now let's break down the range of this network. There are two conditions. Condition number one is the length of this range of network. Because of the /13, the length of range will be from 10.168.0.0 until 10.175.255.255. And the second condition, the CIDR or net mask must be bigger than or equal to 24. There are some networks here. I brought you some networks for examples for understanding better and better. As you can see, the first network is 10.168.0.0. As you can see, the first two octets of this network are all the same with our IP prefix list. And let's jump into the second condition, /13. But in second condition, as you can see, it says that it must be bigger than or equal to 24. But in this network, in first network, it's /13. It is smaller. So this network is out. Now let's take a look at network 2, the second network. As you can see, the first two octets of this network are all the same with our IP prefix with 10.168, and as you can see, the CIDR or net mask is 24. It's actually equal to 24, so this network matches. Great. Now let's look at the network 3, the third network. The IP is 10.104.0.0. It's actually out at the first of condition. Why? Because in the second octet, as you can see, the second octet is smaller than the second octet in our IP prefix list. So it's out as well in first condition. Okay, now let's look at the last network. As you can see, the network with IP address 10.173.1.0 actually matches the first condition. Why? Because of the /13 in our IP prefix list, their IP range is from 10.168.0.0 until 10.175.255.255. So the first condition matches, and the second condition, it's a /28. So as a result, the second condition matches as well. So this network is in our IP prefix match. Perfect. In this example, we have two networks match IP prefix list. Now let's look at another example. We're going to create another IP prefix list with IP prefix list with name, for example, CD, and sequence number, let's say 20. And then it is time to define that it is permit or deny, which is permit in this example, and then we have to input our high order bit pattern, which is our network. In this example, it's going to be 10.0.0.0 with /8. And the second condition. In this example, it's going to be GE or greater than or equal to 22. CIDR must be greater than or equal to 22. And there is another condition. As you can see, it's going to be more and more interesting because there is another condition in this example, right? In the third condition, it says that it must lower than or equal to LE, lower than or equal to 26. And after that, this IP prefix list is created. Now let's look at the networks that I brought you for examples, that considering which of these networks can match our IP prefix list. As you can see, in these three networks, all of the networks actually match our IP prefix list. Why? Because our IP prefix list network is 10.0.0.0 with /8. As a result, the only thing that is important is in this network is the first octet because of the /8. As a result, all of the network's IP addresses match with our IP prefix list. Now we have to consider the rest of the conditions. The second condition and third condition. Now in the first network with /8, as you can see, it is actually lower than 22. So the first condition, the first network, because of the second condition, is out. Network 2, the second network with /30. It actually matches the second condition because it is greater than 22. But it fails at the third condition because it is greater than 26. But it says that the CIDR or your net mask must be lower than or equal to 26. But this is /30. It is greater. So this network is out. Now let's look at the third network with /24. As you can see, it actually matches the second condition because it is greater than 22. And in the third condition, it is actually lower than 26 as well. So this network matches our IP prefix list. That was all about IP prefix list concept in CCNP. Now let's look at the IP prefix list in routing protocols, all of the routing protocols. I'm going to show you how to, guess what, apply IP prefix list in roadmap, and then we have to apply that policy roadmap in routing protocol. We start from EIGRP, for example. We get into routing protocol with EIGRP. After getting to EIGRP configuration, we have to get into topology base. After that, distribute list, and you have to input, guess what? Prefix. And you have to input your prefix list name, for example, AB. And then, guess what? You have to specify that this policy or access list, whatever the prefix list, apply on outgoing interface, outgoing traffic, or incoming interface. So as a result, in the most of the conditions, it's going to be outgoing interface, outgoing traffic. But I'm not going to enter that for now. I'm going to show you that we can actually assign this IP prefix list in our roadmap firstly. And then we apply this roadmap policy in our routing protocol. So to do that, we have to create a roadmap. Name of the roadmap, for example, BB, and you have to input our sequence number, for example, let's say 10. Permit and sequence number 10. And after that, we can easily input match IP address and then prefix list. And the name of the prefix list, whatever it is, for example, AB. And after that, we show roadmap. You can see exactly what is going on in your roadmap policy. As you can see, IP address is your prefix list with name AB. And now you fully understand how to apply your policy which consists of your prefix list, or you can directly assign your IP prefix list into your EIGRP. All right. Now let's look at OSPF protocol. OSPF, for example, 1. And then after getting to OSPF configuration, you can easily input distribute list with question mark. You can see the potential commands that you can input. As you can see, we can actually input our roadmap and then assign this policy with name of the roadmap in your OSPF router, or you can directly input your prefix list with prefix and then your name of prefix list, which is AB or CD, whatever your prefix list is. This is for OSPF protocol. I'm going to show you how to use prefix list in BGP, for example. Get into BGP configuration. Router BGP 11. And after get into BGP configuration with question mark, with distribute list and question mark, you can see that you actually don't have your roadmap anymore. So you have to input your prefix list directly in BGP configuration. Got it? With prefix, for example, the name of the prefix, for example, AB, and you have to specify that actually it's going to apply on outgoing interface or incoming traffic. So for example, it's going to be out, and this prefix list is applied. Thank you guys for watching. I hope you enjoyed that. That was all about prefix lists in CCNP. I recommend you to run your own laboratory at home and exercise in new and different examples. You might face and run into new problems. That's good, because you earn extra information about prefix lists in routing protocols. That's absolutely brilliant and precious. Actually guys, we have a couple of videos with name PBR, policy-based routing, and also routing manipulation. And then we're going to dive into OSPF after a couple of videos. I hope I find the time to get CCNP course done after 1 or 2 months. I really hope so. See you soon. Goodbye.